Good morning, children. We proceed on to the last section in differentiation. We call successive differentiation. The word successive tells me keep on differentiating. For example, if y equal to x power 4, first derivative I will call dy by dx. X power 4 becomes 4 x power 4 minus 1, or it is 4x power 3. Suppose I want to differentiate it again. I call it as dy by dx. Again I put d by dx, which is d square y by dx square. Power 2 tells me first derivative I have to differentiate again. That is y I am differentiating 2 times. So first time I get 4x cube. Second time, what happens to x cube? 3x square. Or I will simplify it as 12x square. Suppose I want one more derivative. Keep 12. X square becomes 2x. That is 24x. Suppose I do once again. It is 24. Suppose I do once again. It is 0. So after certain steps, the derivative may terminate. But if the problem has power minus 4, it will go on and on. So there are problems where derivatives terminate. There are problems where I can keep on differentiating. So we must know to name them. So as I keep on doing, I call it as successive differentiation. Instead of dy by dx, I can call it as y1, first derivative, y2, second derivative, y3, third derivative, y4, fourth derivative, and y5, that is fifth derivative. You can also call the same as f dash of x instead of y. If I call the function as f of x, it is f dash of x, second derivative is f double dash of x, third derivative is f triple dash of x, and I will put and so on. F fourth derivative, f fifth derivative, and so on. In general, if I do it n times, I call nth derivative d power n of y by dx power n, or f power n of x, or y suffix n. Some books we also denote it as y dash first derivative, y double dash second derivative, y triple dash third derivative. So suffix also tells derivative. Power dash, double dash, triple dash also tells me first, second, third, and so on. So derivatives we are going to do in this exercise. If they ask you y2, differentiate 2 times. If they ask you y3, differentiate 3 times. So instead of y2, y3, they may give this notation with t powers, or they may give f dash, double dash, like that. Based on the question, try to attempt it. D square y by dx square is nothing but d by dx of dy by dx. To do in problems, let us remember to write in this way. D square y by dx square, the second derivative is derivative of first derivative. Let us start with exercise 5.9. Question number 1, find y2. Given y equals e power 3x plus 2. E power x, let us remember the formula. E power x, the derivative is e power x. Suppose e power 2x is coming, or let me say ax is coming. e power ax into a. So remember the formula. E power x becomes e power x. E power ax becomes a e power ax. Let us apply that here. Suppose ax plus b is there. Here also I will have ax plus b. This will not affect this number. Let us apply in this problem. I am given y equals e power 3x plus 2. Differentiate with respect to x. Y becomes y1. You can write y as y1 first derivative. E power 3x plus 2. Apply the formula 3 e power 3x plus 2. Again I am differentiating. So differentiating with respect to x. y1 becomes y2. 3 into e power 3x plus 2. Again apply the formula 3 e power 3x plus 2. So what is my answer? 3 3s are 9 e power 3x plus 2. Let us remember the formula e power ax plus b. The derivative is a e power ax plus b. So applying that, I am getting y2 equals 9 e power 3x plus 2. I can also say this as 9 e power 3x plus 2. From the question it is y. So y2 I can also write as 9y, and that is the answer. Either this way or this way I can give out the answer. Second subdivision, find y2 when y equals log x plus a power x. Differentiating y with respect to x. I can call y as y1. Log x becomes 1 by x plus a power x. The formula a power x into log a. My question is to find y2. So differentiate once again with respect to x. What is 1 by x formula? 1 by x becomes minus 1 by x square plus keep log a as it is. Again I have to differentiate a power x. That is minus 1 by x square plus log a into a power x derivative a power x log a. Or I can say y2 is minus 1 by x square plus log a into log a is log a the whole square into a power x, and that is the answer. Question number 2. Y equals 500 e power 7x plus 600 e power minus 7x. Show that y2 minus 49y equals 0. y2 tells me second order derivative. So, first we shall differentiate with respect to x. 500 into, when I differentiate first time, y will become y1. What about e power 7x? Remember the formula, e power ax becomes a e power ax. So, e power 7x becomes 7 e power 7x plus 600 into e power minus 7x is minus 7 e power minus 7x. In these two, I cannot take anything as common. If needed, we can write 7 into 500 e power 7x minus 600 e power minus 7x. My question is with y2. So this is y1. Differentiating again with respect to x. y1 becomes y2. Keep 7 as it is. 500 into e power 7x. Again I am differentiating. Apply the formula. It is 7 e power 7x minus 600 into e power minus 7x will become minus 7 e power minus 7x. Remember, e power ax tells me a e power ax. So, e power 7x is, put the 7 near e power 7x. Here e power minus 7x is coming. So, put minus 7 near e power minus 7x. Minus into minus is plus. Again in both the terms, 7 is common. Already there is a 7. Again I am taking 7 into 500 e power 7x minus into minus plus 600 e power minus 7x. That is 7 into 7, 49. The bracket term is nothing but the given question, which is y. So 500 e power 7x plus 600 e power minus 7x can be written as y. So it is 49y. y2 equals 49y tells me y2 minus 49y is 0, and that is the expected result in the question. Question number 3. If y equals 2 plus log x, then show that xy2 plus y1 equals 0. Given y equals 2 plus log x, differentiating with respect to x, y becomes y1. 2 constant will become 0 plus log x becomes 1 by x. Or I can cross multiply x into y1 equals 1. Differentiating again with respect to x. There are 2 terms in the left. Keep the first term, differentiate the second term, plus keep the second term, differentiate the first term, equal to 1 constant becomes 0. Keep x, differentiate y1, plus keep y1, differentiate x. Or I will say x into y1 derivative is y2 plus y1 into x derivative is 1, that is 0, implies x into y2 plus y1 equal to 0, and that is the expected result in the question. Simple problems provided we know the derivative formula. So log x becomes 1 by x. That is the only thing that we need to remember. As I cross multiply, it is in product. Remember product rule. Keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. RHS being constant will become 0. y1 derivative is y2, x derivative is 1, simplifying which we arrive at the result. Question number 4. If y equals a cos mx plus b sin mx, then show that y2 plus m square y equals 0. Let us differentiate with respect to x. Y becomes y1. A as it is. Cos will become minus sin. Remember the formula. Cos mx becomes minus sin mx into hide cos mx will become m plus b. Sin mx will become cos mx into hide sin mx becomes m. Or I can take m out. It is minus a sin mx plus b cos mx. Let us differentiate again. y1 becomes y2. Keep m as it is. Minus a as it is. Sin mx will become cos mx into m plus b. Cos mx will become minus sin mx into m. Remember, whenever mx is coming, after applying the formula, put m. So, sin becomes cos because of mx into m Cos becomes minus sine because of mx, put m. Now again there is m common. So already there is a m. Now we have taken an m. We are left with minus a cos mx minus b sin mx. Notice in both the terms minus is also common. Take minus sign out. It becomes plus. A cos mx plus b sin mx is nothing but y in the question. M into minus m is minus m square and this term is nothing but y. And so bringing it to the left, y2 plus m square y is 0. We'll quickly rough through the problem. Given y equals a cos mx plus b sin mx. Y becomes y1. A as it is. Remember the formula, cos becomes minus sine, sine becomes cos. Whenever mx is coming, put into m. Taking m out, the left out, once again I differentiate. Y1 becomes y2. Again, sine becomes cos, cos becomes minus sine. Whenever mx comes, put into m. So first derivative, one m is common. Second derivative, another m is common. Also minus symbol is common. Simplifying which, we arrive at the result. Question number 6. If y equals sine log x, then show that x square y2 plus xy1 plus y equals 0. Differentiating with respect to x, y becomes y1. Sine log x, sine will become cos. So sine log x will become cos log x. I completed sine, hide it. I see log x. Log x will become 1 by x. So we have done chain rule. Sine log x becomes cos log x into hiding sine log x becomes 1 by x. Cross multiplying with x, it is xy1 equals cos log x. Again differentiating with respect to x. There are two terms in the LHS. Keep the first term, differentiate the second term. Plus, keep the second term, differentiate the first term, equals cos log x. If I differentiate, cos becomes minus sine. So cos log x becomes minus sine log x, hiding cos. Log x left out. Log x becomes 1 by x. So it is again chain rule. The LHS, x into y1 if I differentiate y2 plus y1 into x if I differentiate it is 1. The whole thing equals minus sine log x. I can write y from the question divided by x. Cross multiplying x into x is x square y2 plus x into y1 is xy1 equals to minus y. Or bringing this to the left, I have x square y2 plus xy1 plus y equals 0, and that is the result given in the question. We'll see once again. Y becomes y1, sine becomes cos, log x becomes 1 by x. Cross multiplying x into y1 is cos log x. Here when I differentiate, x as it is, y1 becomes y2 plus y1 as it is, x becomes 1. Remember product rule, keep the first term, differentiate the second, plus keep the second term, differentiate the first. RHS, cos becomes minus sine, log x becomes 1 by x. Sine log x, we can write y. Y by x is there. As we cross multiply and we bring all the terms to the same side, we arrive at the result.